Okay, so until everyone comes back, so if there are any doubts, just raise your hands. Okay, so we will solve those doubts until everyone joins. So everyone has made their own publisher and subscriber, is it? Manish or Nikhila, is anyone there from you guys?
Yes, sir.
Yeah,
Yes.
okay.
Could you please create a poll right now, like if everyone done with their publisher and subscriber, because proceeding we will be needing that. So please make a poll.
Sure.
So now we will be more looking into like how these nodes, how this publisher and subscribers, we will be binding them together. Okay. So, and after that, we will be looking like we will be using a package that we specially made for IRCKT, and we will be implementing few things over that.
So let me know when to start recording. Okay.
Yeah. Until then, you can just put the poll so that everyone can answer.
Sure.
If there is anyone else who has not, yes, Joel.
So when we publish, so we are publishing something. So in your example, I think you published video title. So and then the subscriber is subscribing to that. Is it subscribing to that particular thing, or will it subscribe to whatever everything that the publisher publishes? Because he can publish many things, right?
Yeah. So the subscriber.
How does that work?
The subscriber subscribe to a topic. Okay. So whatever is published on that topic, it will know everything about that topic. Okay. So just consider if there is a topic, and there is let's consider again a channel, YouTube channel example. Okay. So in YouTube channel, you can either publish full videos, or you can do live stream, or you can have community post, and you can upload YouTube shorts, and there are a lot of stuff, right? But if I'm subscribed to Carry Minati, I will get notification of all these things, right? So that is how it works. So everything that is being published to that specific topic, the subscriber will get everything. Okay.
Okay, so this data is actually all the published items, or everything that is published will come in data.data.
Yes, every data that is.
Okay, fine.
So
is there a way to select what you want from?
Yes, there is a way. I will show you just a minute. Let's do that thing now. So you want specific data, right?
Basically.
Yes, ask, go ahead.
Yes.
So Joel, so message will contain the entire message. So every message has its own variable names from which you can collect data from. Yeah. So for example, let's say I have a message called Sahas, right? Sahas will have name, roll number, or something like that. So when you give a message dot name, whatever you given inside the message name will come out. If you give message dot let's say roll number, my roll number will come out. So if you have some, it's like a class objects, right? It's similar to objects variables. So if you create a class called Joel,
okay.
And you have his name, roll number, and stuff like that, phone number and stuff like that. You give message dot object dot with your variable name, it will come out, right? It's similar to that. Exactly. You know what? It's actually very similar to that.
Okay, fine, I understand. So okay, my question is now is, suppose you do pub.publish title, and then you're publishing something else also. Suppose another title 1 and title 2. Now, if you, in the same way, if you use data.data, what is actually
so in
what
that
actually happens?
Yes.
Both titles will come.
So in that case, whatever title you are publishing it to a specific topic, right? So in that topic, you can have different types. So in one topic, it will be only one data type. So it will be either string, everything will be in string, or everything will be in this thing. So just a minute, I will share my screen. I guess I was not sharing it. Yeah, could you see this? Joel?
Yes.
So here, this is the topic, carry Minati, right? So this topic can only have string type. Do you understand?
Okay. Yeah.
So that is the thing. So you can only publish strings to this topic.
Okay, fine. So,
So let's do one more thing.
Okay,
Let's
fine.
create one more publisher. Okay. Let's create one more publisher. So name it as gamer because Cariminati has a gaming channel, right? So let's type it game rospy.publisher. The name is what is the name of the channel? Carries live.
Carries live.
Yeah. So this is the another channel Carries live. So let's keep this as instead of string we can keep it as integer. Okay. But to use integer you need to import integer as well, right? So import string as well as import integer. Okay. Are you understanding what I'm doing right now?
Yes.
Okay, so we have two publishers. One is pub and another one is game. Okay, so now again we can check something like this video title is done. It will do one more thing. Game number equals to instead of we can keep it here itself. Okay, so control control C, control V, game number. So this will be an integer type. So here we converted it into string, so we don't need to do here with the game number. So we have to just say global game number, and then we can do here not pub, here it will be game. So game dot publish, and what it will publish is it will publish the game number. Okay, and then it will also print the game number. So we can do print game number. So here what it is doing, the pub is publishing the video title, which is a type which is string. So that's the reason this is a complete string variable. And then it will be printing video title, and again we will be also publishing, game will be publishing the game number, which will coming from here, and this is out. And just the way we increase the video number, we can increase the game number as well. So this is done. Is there anything else that is remaining from this? Okay, I don't think this is int. It should be int 32. Yeah. So if you go over to here, other locations, computer, opt, ROS, melodic, share. Inside this, you will type see all types of ROS messages. So if I search for ROS under standard messages, standard messages. Yeah. So inside message. See, you can put int 8, int 16, int 32, and int 64. There are a lot of things. So I will be using, let's use int 64 itself so that it will have all the numbers until now. Right? Int 64, int 64. Okay, I'm done with here. So now what we will do is first start a ROS core. We have started a ROS core. Next, open a new tab, start carry Minati. Ajay Nagar. So I will do ROS run IRCKT and then Ajay Nagar.py. So see, this is the video number which is you. Can you see this? Should I increase the size? Are you able to see this? Yeah. So this video number 12, this is on normal channel, and this only number, this is the game number. So this is being published to gaming channel. So if now I open the let's say Jagmeet or ROS run IRC_KT, and what were the different things? So we have Samya. So Samya.py. Okay. So he is only watching video, Kariminati's normal channel video. So if I run ROS run RQT graph, RQT graph. Here you can see he is only looking at the normal Kariminati channel. But now let's do one thing. In Jagmeet is also subscribed to Kariminati this channel, gaming channel as well. So subscriber, it is Carry is live, and the type is integer, and watch game. We can do this, and similar to this, we will create one more thing, one more definition. So watch game. So now inside watched, it will be I have watched game number. I have watched the game number, and now it will be converting this data that will be coming in the form of integer. It will be converting into string, and it will be printed over here. So now if I start the meet, so open a tab, sorry, instead of opening a tab, I can just split it. Yeah. So here I will do ROS run IRCKT Jagmeet.py. Int is not defined. Oh, okay. So here we need to define int 64 as well. It is int 64. I'm sorry. And here also we need to import int 64. I missed that. Okay. Yeah. Now if I open the RQT graph, yeah. So see, Ajay Nagar is the same person who is uploading to Kariminati as well as Carry is live. And Samya is only subscribed to Kariminati. So he is watching videos only of Kariminati. But Jagmeet is subscribed to Carry is live as well as Kariminati. So he is getting both the subscriptions. Do you understood, Joel? Joel?
Yes, sir.
Okay.
Like if
Yes,
one
sir.
person,
I'm audible, right?
Yes, you're audible. Yes, somebody was saying something.
yes, I am telling that if one person is publishing two different nodes, like two different things, so that will be in one Python script.
So see, one person. So here person is node, and he's publishing to two different topics. Yes. So they are different channels. So this everything is running in one inside node, because see, whatever Ajay Nagar is planning, it's inside his head, right? Even if it's Kariminati or even if it's Carry's life, he is the only person who is publishing to both. If his mind says don't upload to Carry's life, then he won't upload to Carry's life, right? So that is what is happening inside this Ajay Nagar. So he is publishing as a gamer on gaming channel as well as on normal channel. So that is what is happening. Okay, understood?
So if one node having multiple topics, so that should be in one script. That's
yes. You can also have two scripts for both of them differently. You can have that. That is also possible. You can just you have to just initialize node once, and you have to tell the publisher or subscriber. That's it. So that can be.
It can be in different scripts also.
Yes, it can be.
Okay.
Any other question, Joel?
So when one node has, one script has when one node publishes two things, like can you show how you select only one from it?
select only
Like
one
in the subscriber.
in the subscriber. So see now, so now Ajay Nagar is publishing to Carry Minati as well as Carry his life. Okay, now there is a subscriber who is Samya, who only wants to see Carry Minati's video. So he will only subscribe to Carry Minati video. So if we go into the script and see the Samya script.
Okay, so I'm saying if
Yes, go ahead.
Cariminati had 2 videos, I only want to see one of them.
Okay, if you want to see only one of them, so in that case, just a minute, I'll show you. Yeah. So here we are subscribing to this thing. So which video do you want to watch? Do you want to just watch Carry Minati's even video, or do you want to just watch Carry Minati's odd number of video? What do you want to watch? Joel, can you hear me?
I didn't understand.
So see, whatever type of video. So you said you want to just watch Carry Minati's what type of video? Like, do you want to watch so whatever condition is, you can just put a condition over here. Okay, so you can put a condition like if the video number is odd, only then I will watch. If the video number is even, or maybe you can say if the video has a title which says a number which has 23. So whatever condition you want, you can put the condition over here in this definition of watch, because it will only watch if that condition is being satisfied. Understood?
Okay, fine. Yeah. But
how about to make sure that sorry. Joel, you can ask, please.
Go ahead, Joel.
1 minute, I'm on my phone. I'll switch to my laptop. 1 second.
Okay. By that time, Hariyar, you can ask.
So you know that you can add some conditions over here, right?
Yes.
But this is a function, right? Like what will it return, or like how will it know the condition is satisfied?
What are we publishing right now to Carry Minati? Just let me check. We are publishing a video number and last the number. Okay. So we can say, wait a minute. See now this data. So this data, what we are getting is, it is the complete line, which is this video number and the name of the video number. So if we want just the last 2 letters or last 3 letters, so I want to just check if what is the video number, and depending upon the video number, I will choose if I want to watch or not. Okay. So in that case, what I can do is, I can have a Python script. So if you're familiar with all the Python scripting, then you can do this. Okay. So instead of printing instead of printing watch, let's do something else over here. I will do what equals to what we can say the length string data. So I will get the complete data, and inside that I've watched. So I will get the video number from here. I will get video number, which will be from watched. I will segregate the last 3 characters. So it will be length. I will also have to take a length of the character. So length. So don't worry if you are not like professional in Python, you won't need it in this complete IRCKT. This is only for the people who wants to get more into Python programming and stuff. Okay. So watched. So here I am taking first the data that I am receiving, okay, and I am saving it in watched. Then this length, what does this do is it takes the complete length of the watched. So what is the complete length of the watched? So it is like video number 651. This is the complete length of what is watched, okay. And after that, I want to take watched last 3 numbers, okay, or else I can stop it right now, and I can take the only one, last one. So watched will be length length minus 1. So it will take the last character. Sorry, and I will print it. Print video number. So now if I save it, let's check what happens. Okay, which one is this? Samya, right? So I will start video and I will start Samya. Yeah. It is only printing the video number. Can you see 6, 7, 8, 9, and the last one. So whatever, like I am taking the last digit, so it is just taking the last digit. Here -1 means last digit. Okay. Now I will add one more condition. I will add a condition saying if video number is divisible by 2. So have you ever worked on even odd numbers in Python script? Do you guys know how to do it?
Yes.
Modulus 2.
Exactly. So here I will type percentage 2
Answer 1.
equals to 0. So here I am having a condition. If the video number that we are getting, the last digit, if it is divisible by 2, and like how is it divisible? Like if it is divided by 2 and then the remainder is 0, means that is the even number video. So I will, if I choose, like I want to watch only and only Kariminati's even video, even number of video. So I will only watch this. So in this if condition, I will see I have watched Kariminati's video with title this, and I will print it. Okay. So if I save it right now, okay. So now if I start Ajay Nagar, so he is uploading each and every video 1, 2, 3. But now what Samya will do is he will only watch even number videos. What is the problem? Okay, I will just convert it into integer. Yes. Now, whenever Ajay Nagar is uploading, he is uploading each and every video. But Samya is only watching the videos with even number. So he's only watching video number 4, 6, 8, 10, and such like. So if you want specific messages that you want, so you can have any condition over here. So you can have conditions where you want to specific number of terminals. So if I'm using a joystick, let's say I'm using joystick. So only and only if I'm getting this yellow button press, only then this will happen. So you can have any conditions that you want over here. Okay. Are there any doubts regarding this? Yes, Sahil.
I wanted to ask like an alternative to the number part. In the publisher file, script file, can we only publish the number and not the whole sentence?
Yes. So here you can see now we are only publishing just the number.
No, like the here when we are publishing whole the video number, the string part, and the number, right?
No, that is being uploaded to Kariminati. But this number has been uploaded only to Carrie's live. So see, if I remove this publisher, okay, see I'm removing this thing.
Yes. I got that. But you know, while subscribing, when Samya was subscribing, we had to again do that whole string part just to get the number.
Okay.
The last 4 digits.
So Samya was subscribed to Kariminati. He was not subscribed to Carrie's live.
Okay, okay. So we can do the carries live thing in carry unity also. Yes.
Yes. So Carrie's Live was publishing numbers and Jagmeet was subscribed to numbers. So here he was saying that I have watched game number video 660. So instead of 660, you can just get number. And there is one more thing that you can see. I will show you just a minute. So if I just remove this into 64, yeah, okay. So now if I run this and if I do ROS topic echo, okay. So if I open up a new tab, the numbers are being published to Carrie's Live. So if I do ROS topic echo, Carrie's Live, see the data is only and only numbers.
Yes.
Got it? Okay. So that's the reason the technique is only getting numbers in that case. So I was just adding a few sentences if you want. But yeah, this is important because in robot messages, we won't be sending a complete string. We will be majorly sending numbers because we will be sending numbers like how much far does the robot has to go and where it is to go. So those kind of stuff. Okay. So we will be using this thing. Yes, Hariyar, what is your question?
I'm not ready to this. Like in the Pramshu file, you have given a line like ROS_by.spin. What does it exactly do?
Which Pramshu file? What?
A Pramshu.py. ROS_by.spin.
Spin. Okay. Yes. So spin is like a loop. Okay. So this is the loop for this ROS thing. So whenever you are using a subscriber, the subscriber should be subscribed to it again and again, right? It should get notifications again and again. If you don't add ROS_by.spin, it will hear that like whenever Kariminati has uploaded first video, it will hear that. But next time it won't go to the video. Don't go to the Kariminati's channel. So like in our case, I regularly see Kariminati's channel and see if he's uploading new videos. So that is like I'm spinning and just going there again and again. So that is what ROS_by.spin does. So every subscriber should have ROS_by.spin. Understood?
Okay, thank you.
Okay. So now we will be like now you know what is nodes, how everything works. So there is one important thing that we will be looking at right now. So I didn't show you these slides, but this is just how the publisher has been, how to write publisher and how to write subscriber and all these things. Okay, so I will be sharing this slides with you after this session, so don't worry about that. Somebody asked about these slides sharing, so I will be sharing, don't worry, okay? Now comes the launch file. So what exactly launch file is? So right now you can see the work that we are doing is a lot. First we have to start a ROS core, then we have to start a publisher, then we have to launch subscribers, and depending upon how many subscribers we want, we have to launch them all. So we are doing multiple things, right? But what if everything can be launched using just one single command? So for that one single command, launch files are used. So launch file is nothing but when you have to launch multiple nodes, when you have to run multiple nodes, launch file is used. So you see starting multiple nodes. So for that it can be used. And you can set some parameters, values inside launch file that we won't be using. And if by chance, who was saying about the nodes getting nodes dying? Somebody was saying before starting this session. Yeah, so in case Sahas was saying that, yeah. So in case if any of the node dies, if you want to restart the node due to some connection problem, or it can be anything, so that can launch file can do it automatically. It keeps checking if any node, everything is working or not. And lastly, you can define namespaces. So in that case, let's say if I am working with multiple robots, each and every robot is a tortoise bot, let's consider. But every robot should have a different name, right? So in that case, every robot will have different namespace. So that is how it works. So we can also do that in launch files. But here we will be only using launch file to launch multiple things at once. And there is one major advantage of launch file is, right now see, my ROS core is not running. I don't have ROS core running. So, but now if I run ajaynagar.py in this node, what will it say? it says unable to register master node. So there is no master running. It says master may not be running yet. We'll keep trying. So what is happening is master is not starting automatically. We have to launch master differently. We have to launch this differently. So it will take time. But launch file starts ROS core automatically. It starts ROS master automatically whenever we launch it. So these are the advantages of launch file. Okay. So now we will be looking how to create a launch file and how to run all these things simultaneously at once. So now to create a launch file, what you have to do is you have to go into your package. So here we are into SRC, inside SRC, IRCKT. So we already have one folder named as SRC. We will create a new folder, name it as launch. So this will have our launch files. Okay. So I will open it and I will open it into a terminal. So I can go ROS, CD Catkin workspace, SRC, IRCKT, and inside launch. I can make a new file which is touch, let's say youtube.launch. youtube.launch. So the launch file should have ending saying launch. Okay. Hit enter. Now we have it. I will open it in Sublime Text. Okay. Now for this launch, what we can do is first we have to start it. So these launch files are usually wrote in XML based coding. Okay. So for XML based coding, if you have used HTML before, and even if you have not used, don't worry, it's really simple. Everything is into the coding brackets, the Angular brackets. So everything you have to write in this. So first we will be starting a launch file. So wherever there is this something like this, it is starting, and wherever we are giving a slash, that means it's the ending. So this is the start of launch file, this is the end of launch file. Okay. And inside this launch file you can type anything. So first we want to start one node, that is what was the first node, ajaynagar.py. So to start the first node, it is really simple. All you need to do is write node. So we are starting a node, right? So we are starting a node. Inside this node, what will be this node? So this node will be having package, or else what you can do is directly in this bracket itself you can write pkg, package. So what is the name of the package? What is the name of our package?
IRCKT.
So our name of the package is IRCKT. So we have given the name of the package. Then the next parameter is type. So inside type we have to give the name of the file. So here the name of the file is ajaynagar.py. Yes. And anything else? I guess package type, and yes, and the name. So you can name it anything. You can name it exactly the same. So, but usually I keep it the name of the node. So here the name of the node is ajay._nagar. So I will just copy this and paste it over here, Ajay Nagar, and I will give a slash and close it. So this is one node. What you can do is you can, instead of selecting plain text, you can select XML inside this. So you will get more colorful things so that you understand. So we have started launch file, we have ended launch file, and inside that we have started this node. And what type of node it is? We are using the package IRCKT. Type means the name of the file, and the name is name of the node. I will save it. Now usually what I needed to do was I needed to do first launch ROS core and then just go and start the ajaynagar.py. But now if I do ROS launch, so instead of run, this time it's launch, okay, because it's a launch file. So I will do ROS launch, then the name of the package IRCKT, and then the name of the launch file. So what is the name of the launch file? It's youtube.launch. If I press enter, it will start the ROS master and it will start publishing as well. So if I just check out ROS RQT graph, so there I see the node Ajay Nagar, right? It is running. But you might think that these things were getting published, right? So these things were published because like these were getting printed. So how can I get these things printed over here? So for printing that, I can add one more thing, output. And I will output it on screen. If I output it on screen, now if I launch the node, see, it is now giving the output on screen. But usually we don't have it right in launch file, because what will happen is every time, because we will be launching multiple nodes. So right now Ajay Nagar is publishing, so he will print that thing, and then let's consider Pranshu Dopli is subscribing, he will print that thing. So it will be a lot of mess. So usually we don't give output, but if you want, you can. That is one option. Okay, now we launched one node. Now let's try launching another node as well. So another node is Samya. So we have Samya.py. What is the name of the node? The name is just Samya. Okay. So yes. So I can just do this thing. Now, if I do youtube.launch, it has started publisher and subscriber, both of the things, and I can see the ROS RQT graph using just one command. Now, if you want to launch this as well, RQT graph as well, so there is, you can add this thing as well. So again, this is also one node, right? RQT graph. So the package is, we are doing ROS run, so that is a node. So, and then name of the package, which is RQT_graph. And the type is RQT graph, RQT_graph. Okay, you can name it anything. You can name it, let's name it RQT graph itself. And finally, we want output for this. We want output because we want to view it. So output equals to screen. I will save it. And now everything that we were doing, we will launch it using one single command. I have started this. Everything launched automatically. I don't have to do anything else. Okay. Now, if you want to go even further, let's do that. I will close this. Okay, see, now I closed that RQT graph and it closed down automatically. But what if I want to keep it running? So in that case, I can just say respawn equals to true. So if I give that, okay, and also do one more thing. I will also launch again with Samya. I will also launch Jagmeet. So Jagmeet, and here as well I will start Jagmeet. So now everything is running, and I'm not starting raw score as well. Everything is running automatically. Now we have kept respawn true. So if this node gets closed by some problem, it will respawn it. See, it has started. So I cannot close it from here. It will respawn it again. Okay, are you getting what I'm saying? And what if I want to close it? So to close it, I can just check the click on the terminal and press Ctrl+C, and it will stop it all. So this is the magic of launch file. You can respawn things. You can launch multiple things using just one file. Any doubts regarding launch file? Any doubts? It can be anything. So try launching these things on your PC and make a launch file out of it. Okay. Now before getting into this, now I will give you the first task for the day. Okay. So this task is like you guys understood ROS, publisher, subscriber, everything. So right now, a couple of like in the previous slides, I gave you an example of Cariminati and everything, right? So what you need to do first thing is you have to design a computational graph. So just like I am using a presentation over here, you can draw it in Paint, you can use PowerPoint, you can use any other online tool, and you have to make something like this. You have to make something like this, a real life example for ROS computational graph. So just like I gave YouTube example, I gave this example of a house, sorry, about a school. So everybody is registered to the school, teacher is publishing knowledge, so the knowledge is message to the topic, which is science lab, and then students are subscribed to that science lab to get the knowledge. So similar kind of example, you have to design it in PowerPoint, MS Paint, or anything you wish, anything you are comfortable in. Okay, you have to design such thing. Okay, and then you have to make it in real as well. So you have to make it in ROS. So just like I described here about YouTube, I showed that Ajay Nagar is publishing video. Video is the message to Kariminati channel, and I am subscribed to Kariminati. So this is what I made over here, and YouTube is the ROS master. So similarly, you have to design this. After designing, you have to make it. So right now I made this launch file, where this is YouTube, where Ajay Nagar is publishing to Kariminati and Kari is live. And then there are some people who are subscribed to that Kariminati and Kari is live. So similar kind of thing you have to make. You have to take some screenshots of it. Okay, you have to take some screenshots of it, and you have to upload it on social media, either on LinkedIn or on Instagram. Okay, anything. So any of these two things. Don't put an Instagram story. If you are put an Instagram post or a LinkedIn post. So you have to post it, and you have to tag Rigbital Labs and Indian Robotics Community, both of them. If you are using Instagram, tag the Instagram ID. If you are using LinkedIn, use the LinkedIn ID. So you have to tag them both, and also add these hashtags. So add IRCKT, hashtag Rigbital Labs, and hashtag Indian Robotics Community. These three hashtags, because this will be the three hashtags you will be using to track you. Okay, so use these hashtags, and IRC team will be sharing a form with you later on at the end of this session, in which you have to give your name, your all the details, and at the end you have to upload a link to your post. So you should, if you are uploaded on Instagram, share the Instagram link. If you have uploaded on LinkedIn, just post the LinkedIn link, anything. And also you have to post a screenshot of that post. So that is what you have to do for the task 1. And whoever will, like, this winner will be different from the main hackathon winner. So if you don't win hackathon, the main hackathon that we will be going, so you could win this as well. And in that, you will be getting almost goodies worth ₹600. So even if you don't win, this goodies will be delivered to your home without any extra cost. So that is the thing that you will be getting. You will be getting goodies worth ₹600. Plus on ROS mentorship program, you will be getting a discount of ₹1,000. And after that, if you buy Tortoise Bot, you will be getting an additional discount of ₹500 on that as well. So these are the things that you are getting. And even if you don't wish to apply for ROS mentorship program, if you don't wish to apply for Tortoise Bot, but still you will be getting goodies. So if you are interested, you can do this task and do all these things. So take a screenshot of this. This will be shared with you later on as well. So just stay sure about that. Yes, Sahas, you have any question?
Yes. Okay. So what are the judging criteria for this hackathon task 1?
So this task 1 will be judged upon what type of example you have made. So you have to make a real life example. Like I gave you about YouTube. I gave you about school. So that kind of thing you have to think about that. So you have to think what kind of things are similar into real world, which are similar to this ROS computational graph.
That's, I mean, is visuals important? Like
No. Even if you use Microsoft Paint and you just draw irregular circle, it's completely okay. Your message will be the main thing.
Okay. Another question. So if my say my Instagram is private and I'd like to remain in private, so how do I do that?
You can post it on LinkedIn.
My LinkedIn is super weak. Okay, but like I just registered and kept it aside. So that's why I was wondering, is there any other possibility or something?
No, I don't think, because even we have to check if those are like you have shared it or not, and that's the reason. So
Okay.
Try to post it on LinkedIn. And see, I will share one more thing with you. At the end of this session, this complete IRCKT. So at the end, we will be having a session in which we will be telling you why LinkedIn is important and why to share stuff on LinkedIn. Okay. Because as this is like KT and we want you to get the industrial knowledge as well. So most of the clients that we Recruiter Labs get, we get it from LinkedIn. And the reason we get it from LinkedIn is we keep sharing the stuff that we make. Okay, so I would encourage you guys to also upload stuff on that, because if not, you don't get mentorship. Let's consider you don't get internship in Recruiter Labs. That is the major thing in hackathon, the main prize over here. If you don't get it, at least you will get internship somewhere else. At least people will understand about your knowledge. They will get to know what you are doing. They will get to know what special you have apart from everybody else. So please make that thing. And also, I would request you to write a short write-up about your things. So just don't upload screenshot. Give a short write-up. So if you're explaining about YouTube, just give proper examples of YouTube and just type in like, this is the ROS master, this is ROS core, this is what I have learned. So write it in any words. You can write it in Hindi, Marathi, Tamil, Telugu, no worries, because you will be using Google Translate to translate it if you use any other language. But the major thing is we want to know what kind of message you can give to people, what type of thinking you have. So that's the reason we are giving this task. Okay. So even if the artwork is really terrible, it's okay. Even if you are using drawing circles with hand, even you can draw it on paper and just upload the photo of paper. Even that is okay. Okay, you don't have to make a digital art. You can just draw it. But the main thing you need to do is you need to make it in real life, and you have to upload the ROS thing as well. So to prove your thing, like you have to upload one art that can be a paper art or that can be a digital art, and along with that you have to upload this RKT graph. And you can show how it is working in this terminal as well. If you want, you can show that as well. So in Instagram and LinkedIn, you can upload multiple photos, so you can have that thing. Okay. Yes, Samya. What is your question?
Sir, what will be the time given to do these things, and what is the last time to submit?
Yes. So about that, so the time is will be 22 or 23 of July. Okay, you will be getting exactly exact date at what is the deadline. You will be getting that, but it will be similar to the time you get for the final hackathon task. So you have to upload it in similar time duration, and the results will be declared on Sunday, which is 25th of July. Okay. Okay. Yes, Rahul.
Should we use some generic examples, like general examples like YouTube or school, or we can use something like technical also?
Yes, you can use technical.
Okay, thank you.
Yes, even you can use Marvel Cinematic Universe or anything you want. You can like technical, you can use a line following robot example or something like that. But make sure we will be selecting the most unique solution for that. Okay, so just think in that way.
Okay, thank you.
Okay, is there any questions regarding this task? You can take a screenshot. It will be shared later on as well. But anything else about this? Okay, so if you don't have any further questions, so let's move ahead with this. So now I have taught you how you can make your own package, right? So now let's see how you can download some pre-made packages and how you can use them. Okay, so is it possible to enable downloads for the recordings? Team Indian Robotics Community, can you please answer that question?
It's already available, sir. Like whatever we are recording, right? It is already given to the traveling. They can download it. But these people were talking about the quality of 360 right? I request them to download the video and check it. That would be better solution. It's, for example, say 2-hour long video, it would be all approximately 400 MB to 800 MB. For that, you need to download it. You need not like you open the web player. That's not fair. Okay. Hope your question was answered.
I will try it as well. Just wait a minute. Because I checked yesterday's video and that was in good quality. That was not a problem. Maybe the first day video might be a problem, but yesterday's video was okay. Yeah, Manish, I am not seeing the download option. However, I can see make available offline option. So what is that? I'm not understanding.
Okay, just a minute, sir. I will check it over here. Just a
Okay.
I think it might be because like when you're transmitting, right? Who's like, so since you're presenting, I think you can increase the quality in which you present.
So this yesterday's video, it is in 720 pixel size. So and
One, yes. Okay.
yes,
For especially for IRCKT, we will be sharing some pack.
your voice was not audible in detail.
Hi. So yeah, so I was saying Iggy, there is another way where you can download any video regard of the security from Google Drive. So if you want, I can make you try it out on that same video.
Yeah, sure. Go ahead. Share your screen and show it to everyone. That's right. Can you show it now?
No, we can do it at the end if everyone is okay, because I don't want to disrupt the proceedings.
Okay, no problem. Okay, we can do it at the end. Okay. Okay, then let's continue. Yeah. So right now I taught you how you can make your own package. So now let's try out different packages that are already there and how you can download it. Okay. So basically, there are two types of packages that you can download. One are Debian packages. So Debian packages, you can consider it like a proper softwares that are released and that are there on App Store. So like in mobile apps, all the apps that you download are there on Google Play Store. You can download it at any time and every app works. It has been verified, it is secure, there is no problem. So Debian packages are something like that. Those are the stable versions, there is no problem in that. And those are like automatically installed in your PC. We will be checking this later. But the first thing that we'll be checking is source repository. So what this thing is, like as I said, ROS is open source. So everybody over here is developing packages for ROS. Everybody is making packages for ROS and that making softwares for ROS, you can say. So, but let's consider if I am an individual creator. I don't have that much capability to upload it somewhere on the on App Store or Play Store, something like that. Then what I will do is I will create a small website and I will upload my games over there or something like that. So that is what happens in mobile applications. So similarly, in ROS, most of the people upload their projects on GitHub. So is there anyone here who don't know what is GitHub? If there is somebody, please raise your hands if you don't know GitHub. I will explain them. If not, then I will directly proceed. Okay, so okay, Ajay. So you don't know what is GitHub. So GitHub is a website where you can upload your code. Okay, so I will show it to you. So yeah, so this is a place. This is my GitHub page of RickBetter Labs. So here we can upload code about of our robots, and anyone on internet can download it. They can use it. They can try it. So it is like Play Store, but it is like an unofficial Play Store. You can say it like that. Okay. So for the next task, what we are doing is we are starting. We are going to do download a package from RickBetter Labs GitHub repository. So I guess I already have it installed. So I will first delete that and then we can install it again. Okay. So if I go over to here, RBL bot description, I will delete it. Yeah. Okay. So now this is the link to the repository. So I will share it with you guys on the chat. So has everybody received the link? Can you see it in the chat? Yes, okay. Then what we will do is we will download this repository. So how to download this repository? So I will just copy this command, okay, the link of this repository. And where do we install all the packages? Into our SRC folder. So first I will navigate inside the SRC folder. I can delete all these extra terminals here. So I will be into the SRC folder, see Catkin workspace SRC. So this is the place where I am right now. And what I will do is I will type git clone and then the link of the repository. So what it will do is, using GitHub, it will clone this repository. Clone means it will make a copy of it. If I press enter, it will download, and now you can see I have this RBL bot description. So everybody please do this, have this clone installed, and if you are facing any problem, just let me know. If you have installed it, please press yes in this chat.
Hi Pranshu, can
Yes.
you please share the command, the
Uh,
terminal?
the terminal. Okay, just a minute. Can you see it?
Yeah, thank you.
Just a minute, sorry. Yeah, here you go. Okay, so once you have installed this command, so it will install all the packages that we will be using for it. So right now in this package, as you we have couple of launch files that we can use. We have couple of meshes. So these meshes are like the kind of robots, like what you can say, the model of the robot. And this UIDF includes the universal robot description format of that robot. Okay, so whatever the physics parameters and everything else, so everything is into the UIDF. So yes, Samya.
Sorry, actually my net got disconnected. Can you please tell how to install that thing from Big Better Labs?
Okay, so copy this like use this command into your SRC folder.
Okay.
Okay. In chat there is Krish who is helping you. Okay. Yeah. So these are the this is the robot that we are going to use for the further tasks of IRCKT. So maybe you might feel that we are going a little bit fast for this IRCKT, but because there is a lot like restriction about 10 hours, so that's the reason we are going fast. But if you want to learn all these things in detail, so like about Python programming, about launch files, nodes, subscribers, publisher, and even how to make this UIDF. So all these things are taught in the ROS mentorship program by Repeater Labs. So you can join that to understand all the fundamentals of this. But here I will be just focusing on the application, how you can use it. Okay. So now to launch this robot, what we will do is we will be launching a launch file, which is over here, gazebo.launch. So how to launch a launch file? We have to type ROS launch, then the name of the package. Okay. Is there any other issues that anyone is getting? Please raise your hand if yes. Okay, then ROS launch. Yes, Arya.
Should we run this Catkin main after
Yes.
downloading this package?
Yes, yes, you can. But this package, like normally, that is needed only if your package has some specific models and if it has what do you say, specific these things. What is it? C++ files, right? C++ files. So this thing, this package doesn't have any of those. So it is not needed. But yeah, just for safety, we can do that. So you can go into Catkin workspace and do Catkin make. But that is not needed. But yet, if you want to be assured, you can run it. Okay. Usually, I have a lot of packages and it takes a lot of time to make everything. So I only do it when I know it's necessary. If you try it, maybe it will be fast for you. That's not a problem. Done up to cloning. That's good, Samya. So yeah. So after cloning, just do a catkin make from catkin workspace directory. Okay. Yeah, it's done 100%. Did anyone ask any question?
Yeah, I was asking. Then we have to run a ROS launch in SRC.
Yeah, just wait a minute. I will type. So I have ROS launch. After that, we have to type the name of the package. So here the name of the package is RBL bot underscore description. So I will type RBL bot underscore description. If you are tired of writing a lot more things, you can just press tab and it will autocomplete. Okay. So you have to start writing a little bit and then you can press tab to autocomplete. And then we have to start like gazebo.launch. I can do gazebo.launch and I can press enter. And this will launch the gazebo simulation that we tried yesterday. And along with this, you will have the robot into your gazebo simulation. So is everybody done till here? Can everybody try and can everybody see this robot?
So can you repeat the command again?
I will keep it here. Yeah. So this is the command ROS launch, the topmost command. So everybody do till here. If anybody is facing any problem, just raise your hand. Yes, Joel.
So before this ROS launch, what are we supposed to do?
Not ROS launch. ROS launch you meant to see.
Yeah, ROS launch.
Yeah, so do a catkin make.
Catkin make
from catkin workspace directory.
Okay.
Yeah, go into catkin workspace directory, take your terminal over there, and then type catkin underscore make. That will just run all the things. It will build all the things. Okay.
Okay.
Yeah. So people who are using, yes, Samya.
How to zoom in gazebo?
Use a
scroll wheel.
Scroll. Yes. So I will tell you basic commands for gazebo. So scrolling in and out, you will zoom in and zoom out. After that, if you click on scroll wheel, then you can pan. You can rotate like this. Okay. So if you click on scroll wheel, you can rotate, and if you press the left click, you can pan. So you can move it like. Okay. So you can move it in. Aryan, do you have any issue?
No, sir.
Okay. Just mute yourself because there was some echo. Yes, Jagmeet, what is your issue?
Yeah, Gazebo is not opening for some reason and it is giving a Gazebo GUI error. Process has died.
Could you share your screen?
Yeah, sure.
I think you don't have enough space or RAM, I think. Which is a problem in your VM. Are you using VM?
Wait a minute.
Let's check. Yes, Jagmeet.
Yeah, sharing.
Yeah.
Can you see it now?
Yes, I can see it now.
I hope you can see the terminal also.
Okay, just wait a minute. Launch it again.
This is the command, right?
Yes. Are you using virtual machine or anything?
What?
Are you using virtual machine?
No. Dual boot only.
Dual boot. Okay.
I don't know why, but it seems like some issue related to graphic card or something.
Yes. Which graphic card are you using?
Actually, there's a graphic card MX150 in my system, but currently it is the Linux is running on the inbuilt graphic card that is. I don't remember, but the change I would have to change if I would have to restart the system.
Okay. So that would be needed to do the proceeding because
But yesterday it was working without this.
Could you just stop it, like Control C and type gazebo? Just type gazebo.
Okay. Yesterday it was working.
So maybe you have to just reboot it or something. So maybe there was some driver updates that has happened.
Okay.
Yeah. Any other doubts? Is there anyone else facing any problem? Yes, Samya.
The zoom in, zoom out, or panning is not working.
Are you using a mouse or are you using trackpad?
Mouse. Can I share my screen?
Yes, sure. Okay. Yes. Click on gazebo tab first. Like the name type, not that. Just below that there is one more bar. Yes, dash bar. Click on that. Now try. Even now it is not happening. Yeah, it is happening. You should change the sensitivity, I guess. The scroll sensitivity is very less. So try increasing that. Samya, can you hear me? You are not audible, Samya. Maybe you are mute.
Hello?
Yes, you were saying something?
Yes, I am saying any other option or short key to zoom in, zoom out, like anything?
I have not tried it. Just let me try first. I don't think if there is any. I have to look because I have not tried it without mouse.
Like Control and plus key like that.
Yeah, even I am trying. No, there is not any keys that is given. It is just mouse and this thing. How did you get to this view? Because there is some changes. This is not the standard view. So how did you?
I think you can click the home button in the side to make it go to the zoom in a bit, or you can click on the click on the side the models, right? Click on models.
Yeah.
So double click on the one of the models.
Click on RBL bot. RBL bot.
Click on RBL bot. Yep. Double click on it. I think it will zoom in.
Double click on the name. Double click on the RBL bot. Yes.
Yeah. Double click on it. Or check in camera or
do one thing. Right click on RBL bot.
Yes.
Yes. Right click over it. Yeah. Click on follow. Follow.
That works.
Yeah. So now even if your robot moves, the camera will follow that robot. Okay.
Okay. Thank you.
Yes, Vaishnav. Vaishnav, please unmute yourself.
Yeah, can you hear me?
Please mute your laptop if you can. Yes. I cannot hear you, Vaishnav, if you are saying anything. Vaishnav? Yes, Vaishnav, please use just Vaishnav. Vaishnav, you are not audible, so please like log into just one device and unmute yourself. So if you are using, like if your laptop microphone is not working, just mute your microphone as well as speaker and join through your phone. Till then, we can get the question by Krish. Yes, Krish?
I was asking that can we close Gazebo because it is
Yes, yeah, you can close it.
lagging because the fan started to work very fast and my PC was heating up.
Okay.
So I thought, yeah.
Yes, you can close it. You can close it. Yes, Prasanna?
Hi there. So I'm getting this XACRO not found error. I mean, I tried Googling it, but it said that it is expected that this package should already exist when we install Melodic.
Yeah, so could you share your screen?
Okay.
If you want to quickly fix it, it's basically sudo apt install class melodic shadow. Yeah.
Yeah, so this is my screen, like when I tried to launch the launch file and resource not found. So it went through the ROS paths that was here and
Oh
here.
yeah, this is because, okay, this is easy. You just go to your bash RC. You have to sort it, you have to call it only in the order it was built in. This is very easy. I had to go through, I had this happen to me a lot.
So, Prasanna, are you using multiple workspaces?
Yeah.
So you have to source only one workspace at a time.
You have to source it in the order it was built in.
Okay, so I'll just do one thing. I just like comment this and these two are not right.
Opt ROS should be always there, and you have to source it in the order of your in which you built it.
We need Gazebo. Okay, so I think that should probably solve that.
Yeah.
Let's try that. Okay.
Just open up a new terminal or just source it. No, it doesn't directly work. You have to first source the terminal.
No.
Have you okay, can you show me an entire bash file? I think you might have sourced the opt ROS top a little bit up and
no, there's like nothing mentioned in this.
These are regular bash scripts.
So the thing is, if you look at this, I am going at this particular order. So it first checks this and then it searches in this particular ROS path.
Track1 workspace SRC, that's exactly what you want, right?
Yeah. But
so okay, can you go up a little bit? Export, right? So before export, you need to you add Gazebo paths, right?
Yeah.
Yeah.
You have to Gazebo should come down after ROS.
You can just comment it if you want.
This one, Gazebo?
Yeah.
Yes. Gazebo.
Okay, but won't this like prevent Gazebo from opening up?
No. Gazebo is in your path anyway.
Path, ROS melodic path, it is already there.
Okay, so let's give it another try.
Yeah.
Still the same thing.
Did you do cat key make?
Yeah.
Do it once more.
Okay.
Not on this terminal. This is old terminal. Just close this terminal. Yeah, on the new one that you did.
So it is like completed the build. So
just open the SRC folder of Captain Workspace.
Can you also do what's this thing called? Echo ROS package path?
Yes. I was going to say.
Echo ROS.
$ROS package path everything. ROS package path everything in capital.
Okay.
Dollar. Now we'll give tab will work now.
Okay. Package path.
Yeah.
Oh boy. Okay. So it is going in order. So this is our workspace currently, and this is some other workspace.
Yeah, audio pilot. You just you have to just unsource them. Like take it off comment them in the bash RC.
Okay, that I think I already did it. I don't know why it is not.
Open bash RC in your text editor.
Yeah, text editor. This is very hard to read in this one.
Okay, just a second. So So these are like completely commented, right?
You have dollar signs at the end, so maybe it is getting that thing. So,
Oh, okay.
yeah. It has not commented dollar sign. Okay, no, not that dollar sign is like for the continuation, I guess.
Yeah.
Just try like copy paste it something somewhere else, but just remove it completely from bash RC. Just try it. Yeah, even the gazebo and everything, like rest everything else, just remove it.
Okay, I'll paste that there. And then these things. Okay.
Open it in text editor, it will be much easier.
Yeah. Closed on null. So header now.
Control plus H.
Control plus H. Yeah, so this is like completely commented though. So control.
Do you have something in your profile, bash profile, or any other bash?
No, I doubt if something is there in profile.
I mean, I'm not sure if you put it, it might be there.
So there's nothing here.
Okay then. Source it and restart it on. Just put every terminal, just gonna restart.
Okay, sure. So this is fine, right?
Yeah, but you know, if you want, you
just remove it for like safety.
Complete clarity. Okay.
Yeah. Why have it?
X. Less. Okay, I think that was the only terminal open for me.
Yeah, open up and reload.
P. Make. Where's what do we call?
Just type ROS CD and then.
Can make again?
No. Yeah. Just do it once.
I mean, you have only a couple of packages in Track1 workspace anyway.
Okay. Can make. Thing remains same.
Okay.
And ROS launch. What was this?
RBL bot description.
RG bot.
RBB.
Big Better Labs RBL.
Okay, wait. I think that message should be here.
It went above, so.
Yeah. Nah.
What is it saying not found? Chakra.
Yeah.
Have you? Is Chakra installed? Sudo apt install last melodic Chakra.
Yeah.
It comes with melodic pre-defined is what I feel.
Yeah, I know. You know, I don't know.
Okay.
I think it might have been skipped or something. Try it now.
Okay, I think we'll look into this later, and maybe you can continue.
No, it's just a simple command. So I'm typing that command. Just put it in the terminal.
Okay.
Or also try this. Okay, ROS CD Chakra or ROS CD Chakra. You can also find it that way if it's installed.
Yeah.
There's no Chakra. See, there's no Chakra. Yeah, it's not installed. That's the only issue.
Peace.
See?
So did you install the full desktop version?
Yeah. I don't know why it got messed up.
Okay. No issue.
Yep. See, it's working now.
Thanks a lot.
Yes.
Peace. Amazing.
Yeah.
Yeah. Thanks, man. Thanks.
Yes. Any other doubts, Lohit? Yes. Go ahead. Okay, I guess Lohit doesn't have any question. Yes, Hariyara.
Is there any way to make Gazebo run on the graphics card in Ubuntu, like we do in Windows?
Yes, there is some way, but it is like a long way. I will share a video later on, so you can try it later.
Okay. Another
which graphic card do you have?
MX110.
Is it AMD based or NVIDIA?
NVIDIA GeForce.
Okay, NVIDIA will work. Yes, Sahas.
I just wanted to know what are they going to do with this? Like, what is the aim of film? Stuff like that.
So we will be like using some Python scripts to give it some command velocity so that it can move in like specific paths. That is what we are going to do.
Okay, cool.
Yeah. So right now you guys understood how you can launch Gazebo and how you can install packages that are being made by creators. So the package that you install right now was a package that Rickbitter Labs made, which was on the Rickbitter Labs account. Okay. So similarly, there are lots of creators who are uploading their own packages. For example, there is a creator called as Linobot. Okay. The person who made this robot, which is a ROS based robot. So if you want to download this package, they have given their GitHub link. So just like you downloaded the GitHub package of like this robot, you can similarly download this package as well. Even if you want to make something with, let's say, a quadrupedal thing. So there is another package called as Champ. So GitHub, yeah, this is the package. So this has all the different quadrupedal robots. So there are these are ROS based robots. So there are a lot of packages that are available, and this is how you can download the packages that are made by individual creators. Okay, but now what if you want to download like a proper package? So just right now, the way Sahas helped him download Chakro package. So similarly, we will download some packages that are already there. So I want you to download one package, which is Teleop Twist Keyboard. Okay, so we want to control this robot that you saw right now on the screen. We want to control that. So how you could download that package is, so like the way all the phones have App Store and Play Store, so similarly ROS also has a Play Store. So how to access that Play Store? So first we have to type sudo and then type apt-get install. So this will install anything that we tell it to install. But we want to specifically download it for ROS Melodic. So we will type ROS dash melodic. Make sure I am giving dash, not an underscore. Okay, it's a dash. And after that, we have to give the name of the package. So in the case, we just downloaded the Chakro package, which was not installed. So similarly, we will be installing Teleop Twist Keyboard package. So Teleop Twist Keyboard. Okay. So I will press enter. It will ask for my password and it will install it. So I have already installed it. So it says it's to the newest version. It is already installed. So for you guys, I will paste this command so you could install it. So just install it and press tell me once you do it. Jagmeet, are you facing any problem? I saw the chat right now.
Okay. No, I have fixed it.
Okay, great. Okay, fine. So you have to install this package. So what will happen now is we will check what is this package. So similarly, if you type Teleop Twist Keyboard, it will take you to this ROS repository. So it has all the installation commands. So how to install it, how to run it, everything is given over here. If you want to check the GitHub page, you can check the GitHub page. You can check the code even. So this is like the complete code. You can change the code if you want. Okay. So this is the Python code. So just like we published string messages, we published integers. So similarly, it is publishing geometric messages because it is telling the robot to go forward, backward, left, right. So it is geometry of the robot. So that is the reason it is publishing geometric messages. Okay. So we will try that out. Yes, Siddhant. Siddhant, could you unmute yourself? Siddhant Verma. Okay. Then you have given wrong name. So the keyboard only has single E. You have given double E. So that's the reason it is unable to download. Siddhant. Okay.
Also, Vishnu has some problem. So you just maybe after you finish, run the same command and add fix missing at the end. It will
Yes.
work.
Yes, Arya.
It's not related to this. But what is exactly the difference between Cat2 make and Cat2 build? Like, where do we use it?
Okay. So Catkin build, what it does is it builds all your packages from source. Technically, what it does is it whenever
Builds them independently. So you
yeah.
you don't have to, like, if there's some if there's some clashes, it'll take care of it.
So technically, in antivirus software, there is usually a quick scan and there is a detailed scan, right? So you can consider build as the detailed scan and Catkin make as a quick scan. So both of them does similar thing. Most of them get rid of all the viruses that are there on your PC. But what detailed scan does is it goes onto each and every file and just scans it everything. Like even instead of scanning if there is a virus, this file is a virus or not, instead of that, it will open the file and it will check for the viruses. That is what happens. Yes, Sahas, you were saying something.
Yeah, as what you, I mean, you've covered it all. But only one advantage of Catkin build is you can run it everywhere, anywhere from the inside Catkin workspace or like whatever your workspace name. So I usually use it because I don't have to CD back and come back in.
Yeah. So now we have it ready. So now we have installed. So has everybody installed Teleop Twist keyboard? Okay. So now what we will do is we will launch first our gazebo.launch. Okay. If you are facing any issues, please raise your hands. Okay. So now we have. I will make it like this. So now I have this robot over here, and what I can do is I can open up a new terminal and type in ROS run teleop twist keyboard and then teleop twist keyboard.py. So just like we were running all the different nodes, so similarly we are running this node which is called as teleop twist keyboard.py from the package teleop twist keyboard. And if I hit enter, so now it will run. Okay, so just wait. Yeah, so it will say we can move our robot using these keys U, I, O, J, K, L, M, comma, and dot. Okay, so yes, Joel.
So I'm getting an error.
Could you share your screen?
Can I press my screen?
Yes, yes, sure. Yes.
Can you see?
You've presented a screen in your phone and you can't open the camera if you're using your screen like that.
Stop sharing the screen and start with camera.
Why don't you come in with in your laptop?
Okay, I can do that. Yeah, okay,
Yeah,
give me a few minutes.
Okay, Jay, no problem.
Can you share the command in meanwhile?
Okay. Yeah, for running this command, this thing, right? Teleo.
Yes.
I've shared it in chat.
So can I present?
Yes, Joel. Yes.
These errors weren't there before. It just came after I downloaded the twist.
Press Ctrl C. Let the gazebo close properly this moment. So what was happened is it says model name RVL bot already exists. So the previous version, the previously when you opened gazebo, it didn't close properly. Okay, so click on the 9 dots on the bottom left corner of your screen. Yeah, go into system, search system, SYS. Yeah, system monitor. Okay, can you see a search option on the system monitor?
It hasn't opened yet. 1 minute.
Okay. Just open it again. Try closing your terminal. Are you using a virtual machine or a dual boot?
Dual boot.
Yeah. Try one thing. Try restarting your PC because the gazebo is running in background. That is what it is. So there was already an RBL bot that was launched, and upon that you have launched another gazebo. So that is the reason.
So it's not a big deal even if I continue, right?
Yeah, it should work technically. Just open up a terminal and try it. But yeah.
Do I have to go back into Catkin?
No. You can launch it from anywhere. ROS launch. Yeah, gazebo.launch. Yeah, okay. And open another. Yes.
Okay, got it.
Yes. And open up a new terminal, and in that run ROS run RQT. Sorry, not graph. Tell your twist keyboard.
Okay.
Yes. Yes, Pradeep, you are saying something?
I'm getting an error when I'm running that command. It's saying failure keyboard not found.
So have you installed?
Yeah.
Share your screen.
Can you see my screen now?
No, not yet. Yeah, I can see it now. Yes. So run the installation command again. Pradeep, I said you have to install ROS Medic Teleo Twist keyboard. You have installed normal Teleo Twist keyboard. Could you?
Okay, I'll install it.
Yeah. Did you understand what was the problem?
No.
The command that you run for installation, that is wrong. I provided some other command. Please check the command that I sent you for installation.
Okay. Okay.
I will share with the chat once more.
I have shared.
Yeah, okay. Okay then. So I will get back to this point. Okay. Yeah. So right now, what I can do is I can start the gazebo simulation. So this is like a proper simulation. Okay. Just a minute. Yeah. So this is like a proper simulation of everything that is with the real life physics. But there are two factors that are important. One is the factor, and second one is the FPS. Hello, am I audible? Hello.
Yes,
yeah, not 10 to 15 seconds we did not hear anything.
You hanged. I thought it was my issue, but apparently not.
No. Maybe
The
because of
meeting.
the simulation. Yeah, yeah. So is it proper now?
Yes, you can talk now.
Yes, yes.
Okay.
RT, you're talking about what are the two important factors?
Yeah, the two important factors for running this simulation is one real-time factor, which you can see over here at the bottom. Another one is FPS. So basically everybody knows what is FPS. So it is like how many frames I am getting of this complete simulation, which is around 40 to 50 FPS. So that is good, okay. But the crucial factor is the real-time factor. So
what is FPS? I didn't get it.
so FPS is like see, if I move this zoom in, zoom out, so it is like how many frames of the simulation I am getting right now. So that is frames per second. Okay.
Okay.
Yes. Okay. And real time factor is if there is 1 second passed in real world, so how much time has been passed in this thing in simulation. So it is the what we say. It is the relation. It is the relation between the real time and the simulation time. That is what it is.
So can you give an example?
Okay, so see, if in real world, if 1 second is passed, and in simulation 1 second is passed, both are same. So the real time factor will be 1. Okay, but right now real time factor is 0.1, almost 0.1. So what does that mean is, if in real life 0.1 sorry 1 second is passed, then in simulation only 0.1 second is passed.
Okay.
Okay. So like it will require, with that rate, it will require like 10 seconds in real life will be 1 second in simulation. That will be the relation.
Okay, thank you.
So that is the case. So this will improve and decrease depending upon the processing power of your PC, depending upon what all things you are running. So right now I am streaming my webcam. I am using a virtual machine inside which I am using the complete thing, and there are a lot of things going. So that's the reason the real time factor is 0.1, 0.7, something like that. But when I'm not running any of this, when I'm only running Gazebo, at that time I get a real time factor of 0.7, 0.8. So it should be close to 1. That's the important, close to 1.0. Okay. So the better it is to close to 1.0, that is better. So right now that's the important thing. Next thing is the real time and the simulation time. So here you can see that at the time which we were talking. So after starting the simulation in real world, 3 minutes and 40 seconds have been passed. But in simulation, only 39 seconds have passed. So this is the number that we get from here. Do you understand?
Yes.
So this number is being calculated depending upon the variable real-time factor. So this real-time factor doesn't remain the same at all time, right? So due to that, this real-time factor is like this sim time is being changing. So it does calculation again and again, and that is how it does all the simulation. So if you want to check out the physics, what you can do is I am selecting this this 4 arrow thing. I can click the robot and I can take it up and I can drop it from a height. So you can see it fell from a height. So it falls like a normal robot. It's with every real-time physics. So I can just do one thing. I can pause the simulation. This is the pause button. I can pause the simulation. I can take the robot top and then I will rotate also. I can rotate it something like this. So currently the simulation is paused. So the robot is in midair. If I see like this, it is in midair. Now if I play the simulation, so it fell like a normal robot. Do you understand? So this is how you can make some translations. Now we downloaded the teleop command, teleop package. So what you can do is you can run the teleop package and you can move the robot around. Okay, so the simulation is running. Yeah. Yes. So using I, your robot will move forward. Consider these right side keyboard keys as your what we say arrow keys of the right side. Okay, so I will make it go forward, J will make it turn left, L will make it turn right, and comma will make it go backward. And if you want to stop the robot, press K. So you don't have to continuously press it. You can just press it once and it will go on forward until and unless you stop it. So that is what going to happen. And then you can use UOM dot. So these will make it go forward, like forward, right, forward, left, something like that. So usually what I have to demonstrate, do you have anything? I don't have a robot right now with me, but let's consider this is the robot. Okay, so if I press I, it will go up. If I press comma, it will go down. And if I press J, it will turn like this, L like this, and then forward right, it will go something like this. So instead of forward right, forward left, backward left, and then K is for stopping. So now I first select this terminal. You have to select this terminal. Okay, you have to click it, and then after that you can use the arrow, this IJK button to move the robot. I can move it around. So can you guys try moving the robot around? Yeah. So now let's like everyone, I can see everybody can move their robot. So what we can do is I will open up a new tab, okay, and I will see what is the RQT graph. So if I do ROS run RQT graph, RQT graph, yeah. Yeah. So what is happening is this gazebo GUI. So like this gazebo complete simulation. This is one thing, and we have one node which is teleop twist keyboard node that we are controlling it with right now. Okay. So yes, Samya, we will get to you within a couple of minutes. Okay. So yes, this teleop twist keyboard is one node, and then gazebo is another node. So this teleop twist keyboard is sending messages to the topic command velocity. So command velocity is the topic on which we send the commands for the robot to move, and then that gazebo is subscribed to command velocity. So whenever gazebo sees that there is some command velocity, it will take that and it will give to the robot. So that is what is happening right now. So when it comes to real robots, so instead of sending gazebo subscribing, at that moment real robot subscribe to that topic, but everything else is exactly the similar. So this way you can move the robot using teleoperation. So
what was the upper node for gazebo GUI?
So this is for like controlling this thing. So you can rotate the gazebo and everything else. Nah? So you have an interaction with gazebo. So whatever you interact with. So this is thing. So you can experiment with it. And until then, if you have any doubts, just ask me. We can solve that doubt, and after that we will get into the automation of robot. So any doubts? Yes, Samyan, go ahead. And don't keep your simulations running. It will take a lot of CPU power as well as GPU power. So if you are not using, just close it. Yes, Samya, go ahead.
The command teleop command is not working. Like it is not going forward or anything.
Okay, could you show it?
Yes.
Share your screen.
Oh.
Okay.
So if I now I'm pressing I and nothing.
So again, I said you have to click on the terminal. You have to select on the terminal. You are giving the command from terminal. Yeah. So now place the terminal somewhere like in a side. Yes. Now first click on the terminal. Now press I. Your robot is moving.
Okay. Yeah. Okay. The terminal was not.
Yes.
Okay. Thank you.
So anybody else? Any doubts? can we have, like, is there anyone else who is not able to do it? If you are able to do it, just press like type yes in the chat. If not, then please tell me. Okay. Okay, that's great. Now everybody is able to do it. Okay, so now let's do one thing. Now you know how to control the robot manually, like how you can control it using your keyboard. Similarly, there is also one node that will help you control the robot using a joystick. So if you have one joystick like this at your home, you can even control the robot using that. So that would be a homework. That it is not anything, but if you want to try out, you can try this out. Okay, this is something interesting. But apart from that, let's check how we can automate the robot. So like the way we made nodes for our robot, for sending some data, some receiving some data. So similarly, we will send and receive data for our this simulated robot as well. So now let's make a node. So could anybody tell me how to make a node? Raise your hand, and raise your hand, and I will choose one person. So we will be making a node, just a node, simple node. Yes, Viswa, how to make a node? Tell me.
We have to write this script.
Okay, so
and put that in the launch file.
Okay, so can you see my screen right now?
Sorry, sir.
Can you see my screen?
No, sir. I can't see your presentation.
Okay.
Yeah, now I can see.
So now help me one by one. How can I create a script? Tell me.
First, we need to get into the path, the rig.btl folder.
Okay. So the rig.btl folder. So how should I go into that?
CD. CD package name.
But right now I'm in workspace, Catkin workspace. I have to go into SRC first.
Yes, sir.
And then CD rig.btl labs, right?
Yes, sir.
RBL bot description.
RBL bot.
Yeah. Okay, I'm here now.
Sir, 1 second, sir. I'm checking.
Yeah, sir.
We already have the launch file.
Yes.
And we have to create SRC folder here.
Yes.
To store the scripts.
Yes.
So mkdir src.
Okay, okay. You can do mkdir src, or I am just making a new folder like this. Both works. Okay.
There we need to create a Python file.
Okay.
The name of the node.py.
Okay, but where in RBL?
The src folder. We have to get into the src folder.
Okay, great. Okay, so here I will make a file. What should we name it? Auto.py. I will name it auto.py. Okay.
And we have to edit the file. So get it auto.py.
Or else just.
Or the IDE we want to use.
Yes. So I have used plain text auto.py. Yes. Now that is great. So we have received this thing. Now we have to also make it executable. So before making it executable, let's check out what we did with other things. So this was the sourcing. I will just add this. And now if I do ls, I have black colored auto.py. If I do chmod plus x and name of the script auto.py, now if I do, it's green in color. So it means it is executable. Okay, but now there are a couple of things. So just let me go back. Yeah. So in this publisher, so we will be importing ROS.py because that is like we are using ROS in Python. So that is necessary. Done. After that, do we need standard messages for this? Are we sending string and int? So this time no, because we will be sending geometric messages. So we will be sending the command velocity to the robot. So if you go back, if you check this teleop twist keyboard package, so let's go on to their GitHub and understand what they are doing. So if we check their Python script, okay, so they are using geometric message. So let's import this geometric message. Control C and Control V. So yeah, I have imported these two things. After that, what we used to do is we used to make this thing a publisher node. So this was like a main part of the Python script. I will paste it and automate. I will name it automate. And I will make a definition of automate. Okay, is everything set? Yes. Okay, now we have to initialize the node. So again, you can just copy paste from here. I will just copy paste this whole thing and we will edit it there itself. So I have copied this now. Okay, so first ROS.py initialize and the name of the node. So here name of the node, I will name it controller. You can name it anything. So I will name it automatic controller. That is better. Automatic controller. Okay, now this is a publisher which is publishing to the topic. What is the topic which we want to publish on? We talked right now.
Command velocity.
Yes. So it is cmd_vel, command velocity. So to this topic we are publishing because our robot looks for this. It is subscribed to this. The gazebo environment, it is subscribed to this command velocity. And what type of message it is? Is anybody else? Vishwa?
Geometry messages.
Geometry messages.
No. It is not geometry message. Geometry message is the type of is the wholesome type of message. Yes, Siddhant is right. It is twist message. Okay, so we are importing twist. Remember, so just refer it from here. Okay, and then so this time we want to send it continuously. We want to send it at a higher rate. So I will set it at 10 Hertz because your robot will be like, let's consider if there is a robot who only receives command once in 1 second. So obviously it will go and hit something in 1 second, because if it is moving very fast, it can hit anything in 1 second. So that's the reason I'm keeping it less. I'm keeping the frequency more so that it gets more messages. Okay. Then again, while not ROS.py shutdown, what I will do is I will just remove this. Now we have to publish. We have to publish one specific type of command. So let's check how Teleop twist keyboard was publishing. Okay, so if we scroll down, let's search where is their publisher. Yeah, so see, they are publishing to command velocity, twist message, queue size was 1. That is okay. Where is pub.publish or something like that?
Once you went past it, go up a little.
Yeah.
Go up a little more. Yep, publish.
Publisher, yes. Okay. So they are publishing twist messages. So this twist message consists of a lot of things. So here it is like twist.linear.x. Okay. So twist.linear.y and twist.linear.z. And after that, twist angular x, twist angular y, and twist angular z. So what are these things? Okay, so whenever you have a robot, so for this I need a robot to explain. Just a minute, I will get one.
By the way, if you guys want to know why it's called linear and angular, there's a way for it. You can search for geometry messages twist in Google. It'll give you a HTML page, and it'll tell you what the message contains. It'll look something like. Patrick, can I show them the message type? Geometry message twist.
Which one? Okay, sure. Go ahead. Sure.
Yeah.
Sahas, are you there? Yeah.
Yes, I am there. I was just, setting up. For example, if you want to see geometric messages underscore twist, you do geometry messages.
Your only one screen is visible.
I didn't. There's stuff going on, but that's why I didn't. Okay. Can you see my screen though?
I can see the RBL bot description.
Yeah, I was about to. I didn't type it yet. So you guys will get something like this. If you search for geometry messages twist, you get geometry twist documentation. You click here, it will tell you what it is. So there's two vectors, basically vector 3, which is a linear type, and vector 3, which is angular type. So in this, if you can see here, there will be geometry messages underscore vector 3, then the linear. So this is like in C++ and C and all, you do int x equal to 5, right? That's similar to this. This is going to be the type of message it's going to be, and linear is the variable name. So it's still a vector, but it is linear vector. It's named linear so that you can access it. So in Prantal's
okay, I will chill, sir. I will explain in a.
Now he'll take over.
Yeah. So see, I don't have a robot right now, but I have this toy over here, so I will explain it with this toy. Okay. So let's consider this is the front of the toy. Okay. So either this toy can go in straight line, like linear, like this, in all the directions. It can go straight, or it can go in angle. So it can rotate like this, can go like this, or even it can rotate like this. So in ROS, the front is considered as x-axis. Okay, so now let's consider this is the front. So this is forward. So on my screen, can you see linear x? Should I increase the size, or is it visible?
It's barely visible. I think you need to increase the size.
Okay. Yeah. So this consider a twist linear x. So this means if this is the forward. So whenever I give twist linear x as positive, this robot will go like this. If I give it negative, it will go back. So this is linear x. So it will go straight forward linearly, linear back. Similarly, twist linear y. So y is like the side direction. So if I give it positive y, it will go towards this direction. So this is its left hand side. Okay, so left is positive y, right is negative y. That is how it happens. And in z, up is like the positive z, down is the negative z. Any doubts in this? X is forward, backward, y is left and right, and z is up and down. So these are linear. Now angular. So angular x means the x basically is this, right? So similarly, x means rotating like this. Okay, so you can consider it as roll. So most of the people who has worked on drone, they might be knowing about roll, pitch, and yaw. So roll, pitch, and yaw are angular x, angular y, and angular z. So this is the x-axis as I discussed. So along this x-axis, if you rotate this, so this is x, angular x. Then next is y. So angular y is along this axis. So if I put a rod like this, this will rotate like this. So this is pitch. So this, if I change the angular velocity like this, it will go up and down. And finally the z. So the z is like this axis. So if it looks like this, angular z will be affected. So now in our case, there is a 4-wheel drive robot. There is a robot with 4 wheels. So can you guys tell me what all things will be important? So because see, our robot can move forward and backward. That is possible. So our linear x will be usable. So we will be using linear x. Now tell me, can our robot move in y direction like this? Can it go sideways?
Yes.
Yes. Why can it go sideways? Samir, tell me.
Because its base is fixed, so it can't move up and down, up in z, but it can down in z. but it can like left or right movement is if I followed the forward is X and it is moving sideways, so it is in Y na.
Again,
Like,
I will explain you once again. Okay, in Y, linear Y means the robot will look forward and it will go sideways like this. So do you think our robot can move like this?
no, it can.
So our robot rotates, right?
So linear X and angular Z.
Yes, exactly, exactly. So whenever you are using most of you might be knowing about Magnum wheel robots, Omni wheel robots. Do you know about that?
Yes, yes.
Those are using so those robots can go sideways. So at that time you will be using this linear Y stuff. Okay, but if you are not using that robot, in that case you will be only using linear X and angular Z, because our robot can rotate and it can go forward backward. If you wants to go something like this, so it will be a combination of forward and angular. So this is how it will go, right? It is a combination of both. So that's how the robot goes. Do you understand this? Any doubts in what I explained? Yes, Abhijit?
I'm having robot right now. May I help you anyway?
Yeah, sure.
Yeah, okay. Wait a minute.
Yeah.
Okay, that's.
Yes, Abhijit.
Yeah, I said you will give me what I should do, then you will explain it properly. I think.
Okay. It's okay. So, can you show me how linear X will work in this robot?
It's a positive X.
Yes.
Positive, negative X.
Negative X. Exactly.
Positive Y. Negative Y.
Yeah.
It's a positive Z. Negative Z.
Okay.
And it's
So
a
now,
linear.
yeah. And tell me about angular.
And it's
Angular X. Angular X. So what is the x-axis? What will be the x-axis? So see,
forward and backward.
Yes. So consider a line going forward to backward. Now in this axis, how your robot will move?
It's forward and.
In angular, how it will rotate? If there is a line.
Yes.
So see. No. So you have a hole in your robot in front, right?
Yeah.
Yeah. So consider there is a screwdriver in that hole. So it is holding it like this. Okay. So now how your robot is able to move? Is it able to rotate like this? Only this is possible, right?
Yes. Yes.
So this is angular X. Okay.
Okay.
Now this is the Y direction, like from here to here. If you put something like this, if you put a line,
if it's Y, then Y it might be like this.
And Z is something like this. How will Z will act? Z will act like
yeah. It's okay. Got it.
Yes. Okay. So now you guys understood. We will be using only linear X and angular Z in our case. Okay. So now let's try to publish these things. So if you have any doubts, just raise your hands. Okay. Yes, Gagmit.
So are these bots that are called skid steer? Matlab, I've just heard the name. So is this the one what is called skid steer?
Yes. So four-wheel drive robot where actually skid happens, that is called as skid steer drive.
Oh.
Yes. Okay. So yeah. Yes. So now we know we have to publish command velocity, like twist message. Okay. So how should we publish twist message? So first let's make let's make a variable. So we will say it move command. So this is the command for moving, and it will be twist. So I will open and close twist. Okay, like this, and inside that I will say move command dot linear x. Okay, linear x equals to anything. So I will give it 1.0, and then move command angular z dot z equals to 0.0. So right now I will just give it 0.0, and I will tell you how it actually works. Okay, so I will remove this, and just the way we were publishing pub.publish, and inside that we were publishing the video title. So instead of that, we will publish move command. Okay, and then rest of the things is we don't need it. Okay, so now what is happening is we are making a variable which is a twist type, and inside that we are giving linear x as 1.0 and angular z as 0.0. So linear things are measured in meter per second, and angular things are just a minute, yeah, angular things are measured in radian per second. So do you guys know what is radian? So radian is like a type in which you send an angle. So just like we have degree in angle, yeah. So similarly we have radian. So it means right now I am sending 1.0. So this means our robot will go forward, linearly forward, with a speed of 1 meter per second. So we are sending our robot speed of 1 meter per second, and angular is 0. So means angle, it won't turn, it will just go forward. That is what it will do. Okay, now if I save this auto.py, okay, I will remember this. So now I will start the simulation first. So where is the simulation? Yeah, we'll start gazebo. Okay, gazebo is started. Okay, you can see the robot. I will click follow so that it will follow it. Yeah, okay, and now if I run this script, run this node, ROS run, the name of the package which is RBL bot, description, and then name of the node which was auto.py. If I run that, see, the robot is continuously moving at a speed of 1 meter per second. It will never stop. It will just go on and go on. Okay, and it is going in straight line. It is going straight forward. So that is what it is like. We are sending it command velocity forward. So if I stop it, it won't stop because we didn't ever told it to stop, right? Even if we are not sending command, but the last command it received what 1 meter per second, right? So we have to make it in such a way that whenever I close the script, it should stop. So how can I make that? So see, you see here it is doing like ROS interrupt. So what does this mean is whenever it gets closed. So whenever it gets closed, we can send it to send a command. Okay, so what we can do is we can make another definition, send command. Okay, yeah, or can we do it like this, or just a minute?
Make the publisher global.
I was thinking same, but it will make them confuse more. So
that's true. Or take it and put it next to geometry messages, like line number 6 or something. So it will be, you don't have to do global.
What should I do? You're saying?
Just put the ROS by publisher outside. That's okay. All. Now it's global. No.
So initialize also I will make it global. Something like that. So right now what we are doing is we are making this as global. So it will be called from anywhere. Okay, even this can make it global. Okay, yes. So now, if this happens, so then what we can do is similar way in which we are sending this command velocity, we can send it from here as well whenever we stop it. Okay, so here I will put move command twist linear. I will send 0, so it will stop. Angular we don't need it, so it's okay if you don't send it, and we will publish it. Okay, so now whenever I start the script, first launch the simulation. Okay, so now if I run this script, the robot should start moving forward. You can see it is moving forward, and whenever I stop the script, it will stop. The robot will also stop. It is moving forward. If I stop it, no, it didn't stop. I guess it didn't work. Wait a minute.
I think we have to like, yeah, it's stopped now. I think, or did it just close and the gazebo is closed?
Okay.
But yeah, I think it might be because you need to sleep for a bit for it to go, for it to recognize that it has come.
Okay, okay, just wait a minute. Let me try. It is moving, and if I stop it, no, if it's not stopped. We are making some mistake in the Python code. Wait.
I think at the end you need to sleep for a bit. I think that's it. To publish, you need to sleep, right? After
I think you
publishing,
have to call the global variable.
Publish is a global variable, so is rate. So that's it. That's not an issue.
No.
But you've created like two different instances of twist function, right? So is that an issue?
No.
It's not a function. It's just a class. Right? So it's like a variable. So that's fine. That's not going to affect it.
I will do one thing. So
Once you create a separate function called set velocity, make everything, put everything, all this thing into that, and just in the loop itself, just make it only have what velocity it needs to go in. Like, for example, 1000. Like if you want to do that, you can do that, right?
okay, could you share your screen and show others what you are trying to say? Because I didn't get what you are trying to say.
Okay, I'll show. Give me a second. I'll have to open everything.
Okay. Yes, Samya.
I am not getting this twist thing. Like, what is the whole point of this twist and making this script? Like controlling that to a node automatically, like that.
Yeah. So currently, what we are trying to achieve through this is right now we are sending manual messages, right? So we are controlling it manually.
Yes.
But now we will try to control it autonomously. So we will just tell it to go forward, then left, then right, something like that, and it will. We have to just run one script, and it will make the thing automatic. So we don't
like we can program like this. Like if we program like make a circle, and it will make a circle and stop like that.
Exactly. Yes. Right.
Okay.
Yes, Sahas, you are.
Yeah, I'm looking for variable. Let's say well. Okay, so make just put everything in the. Other than this, I'll just put these two into. Basically, put it out there so that it we can use it as a global variable. Rate can be set inside.
Sas, could you just carry? I will check because I have created this code. I will check that by the time. Okay.
Yeah. Bye. I'll stop presenting.
Sahas? Hello?
Yeah, tell me. Sorry.
Yeah. So here we are creating this script, auto script in SRC, right?
Yeah.
In RBL bot description.
Yeah. No, I.
So every time.
Okay.
So
Yeah.
every time we download a bot from the GitHub, we have to create SRC.
No, not necessarily. If you don't want to mess with it, you can have a different package for itself, and you can control from this package to that package. But yes, if you want, you can create an SRC. But SRC
so like how we have created a package earlier, we can use that to
create a package. You have an SRC folder inside that. Use that to create a publisher called command velocity. In this case, command velocity, but anything if you want in the future. And use it to control that. For example, for now, I'll show you my screen. See, I didn't want to mess with the RBL description file. So what I did was create a new folder. So listen, can you see my screen?
Yeah.
So yeah, can you see my screen? So yeah, I didn't want to mess with that because it's not my file. Last projects. Yep, see, IRCKT. See, this is what we cloned, right? I didn't want to mess with it, so I created a new package called RBL bot control. I put my scripts in this.
Okay.
Or that part. I just didn't want to, mess with it and make it not work. So I mean, suppose if I have to pull in new changes, it will not work because it will cause an error. So I didn't want to do that. So that's why I'm,
Yeah. I got it.
Do you guys want me to see the code in typing out?
No, I'm seeing the screen.
Yeah.
Like the presentation screen.
Okay. Do you want me to show you guys the code, like what I'm doing?
Yeah, that will be better.
Okay, we have like a small simple solution to this. Instead of doing it this way, could you guys see my screen?
Yeah. No, you can't. We can't see your screen.
Just a minute. Okay. So whoever have worked on this before, Python, so we'll use a simple thing like I want the robot to go forward for 1 second and then stop. If I want that, what I can do is I don't want to loop it again and again. So first of all, I will remove the loop. Okay, I just want the robot to go forward once for 1 second and then stop. And so now, and rate.sleep is not necessary because it won't be looping again and again. It will be just for 1 second. Okay, So sorry, it will be just for one time, so read is not necessary. So what I will do is I will first import time. Time, because I want to make sure that for 1 second it goes forward. So what it is happening is right now it will start the node, it will make a publisher, and it will say move command, which is twist. Okay, now I will set linear x as 1.0 and angular z as 0.0, and it will publish it. So now the robot will go on and on for almost like until forever. So what this was what was happening. So now if I do time dot sleep, and if I press 1, so this 1 means 1 second, so it will sleep for 1 second, and after 1 second sleeping, what it will do is it will again like this thing, it will stop it. So for 1 second it will put command velocity, which was 1.0, and this stuff, it will publish it, then it will keep that velocity for 1 second, and after that it will publish 00, it will publish it again. So this is a simple thing that we are doing right now. Okay, so let's try if this works. I have started gazebo. There is our robot. So our robot should go forward for 1 second and then stop. So okay, it didn't even move any a little bit. So let's make it something more. Let's make it 5, if that works. Okay. So there is one fundamental thing that I forgot to mention. So whenever the first message that you send, so first message is considered as a handshake message. Okay, so just like if I meet Sahas someday, first thing that I will say is hi. He won't remember that I have said hi. He will just I've met Pranshu. So just that was the handshake message. So whenever the first message is being sent, it is the message of handshake. So I will just give first message as 00. This will be the handshake message. After receiving handshake message, after 1 second, it will send another message which will tell it to go forward for a time period of let's say 5 seconds. And after 5 seconds, it will send one more message which will tell it to stop. So now if I do it, yes. So now it will keep on moving for 5 seconds, and then it will stop. Understood what happened? Any doubts?
So the first message is just a dud, the basic dud,
Yes,
like it will not work.
Yeah, you can say it did not work, but it is something like a handshake message. So it usually is used to initialize the communication between two nodes.
Okay.
Yeah.
So every time we write something like this, we have to write a handshake message.
Yes.
Okay.
So and handshake message usually are used for physical robots, like they are used as emergency stop buttons as well. Okay. So whenever let's consider that you have attached your robot with some motor driver and battery, and it's going haywire. So at that time you can just initialize the handshake message to stop everything, and that's the reason I'm giving 0.0.
Acha. Okay.
Okay, so that is the case. So now using this handshake, using these like what we say set of instructions, we can do a number of things. So now what we were doing is, this was the handshake message, this first part. So I will just keep it something like this. Yeah. And the other part said move ahead for 5 seconds. Okay, and then stop. This was what was happening. After stopping, I will say it stopped for 1 second. So I can make a sequence out of it. I can make a sequence like go ahead for 5 seconds, then stop for 1 second. Then again, I can keep on making a sequence like this. So now if I make this sequence, I will save it. And now if I go into Gazebo, and if I execute this sequence, so the robot should go ahead, stop. See, stop. Then again it will go ahead for 5 seconds, then it will stop. So this is what is happening. So it is again stopping. Okay. Just wait some minutes, Pradeep. I will get back to you guys within a couple of minutes. So yeah, so this is what is happening right now. But now if I want to, let's make a square out of it. So now our robot is moving. I know this robot is moving. So how can I make a square out of it? So along with telling the robot to go straight, I will also make it I will tell it to rotate. Okay. So you can see first it was the handshake message. Just leave it. It is going straight for 5 seconds, then it is stopping. After stopping, I will give it a angular velocity to rotate around itself. So let's give an, I will remove all these things that are ahead. Yeah. So this is handshake message, go forward for 5 seconds, then stop. Then again, I will sell, this time no linear velocity, only angular velocity. So I will give it an angular velocity of around, so this is radians per second. So radian means you can convert this, do the conversion online. So radian to degree. Yeah. So 1 radians is 57 degrees per second. This will be the speed of the robot. But I want the robot to rotate complete 90 degree in 1 second. So I will give it something like 90 degrees. So 1.5, 1.57. Okay. So I can give it anything. So it's upon you. So let's give it 2 radians, 2 radian per second, and I will tell it to go like rotate for 1 second and then stop. So now let's see if this happens or not. Okay, and how it acts. What is happening? First is handshake, going forward, stop, then rotating, and then stop. This is what is happening. So this is our robot. Let's see what happens if we run the script. Yeah. Are you able to see it?
Yes.
Actually, this while streaming, the simulation slowed down very bit, so that's the reason it didn't rotate properly. So even you can see it in slow motion. So we will try to do it again. Okay. So this time with a little bit more sleep. So let's say for 5 seconds. I can also increase the rotational velocity. I can guess 5 radians per second. So the robot is moving forward. It will stop, and after that it will rotate and stop. But it has rotated a lot. It has rotated almost 180 degrees. But I don't want to rotate it this much. I just want to rotate it a little bit. So 5 seconds instead of 5, I can give it 2.5. So now I can check how the robot behaves. It is going forward. It will stop, then it will rotate. It will stop. Yeah. So this was pretty much accurate. It was not perfect, but it was a little bit good. So what we can do is we can just, I don't want it to go such ahead like 2.5 seconds. So yeah. So right now this is the handshake. So just leave it. So what is happening? Forward, stop, turn, stop. So now if I copy this command 4 times, now this should create a square, right? Because it will go forward, rotate, go forward, rotate, go forward, rotate. It will do again and again, up only 4 times. So this is what is happening right now. Okay. So now our simulation is running perfect. I will start the script and let's say the output. So robot is going forward, stopped. And again rotate. Okay, there was again some lag. So there is some lag and inconsistency because of the streaming. But what I will do is I will send you some videos about how you can do this exactly, because I have already done it and I will be sharing the videos about this same. Let's try it once again and let's see if it doesn't lag this time. Let's hope it doesn't lag. Yeah, it went, but it is not a perfect square, but at least it moved like this. So what we can do is we can just tune the things. So now whenever I have to change the angles or whenever I have to change the time, I have to do it again and again in this thing, right? So instead of that, what we can do is we can create a loop. So instead of doing it this way, yeah. So what we can do is we can create a loop. So this thing can be sent inside for I in range 4. And in this thing, I can tell, yeah, I equals to I plus 1. Okay. So what will happen in this is this is a for loop in Python. So if you guys know Python, so this complete thing will happen for 4 times. So that is what it will happen. Okay, so instead of writing it again and again, I can just tune it here. And right now I saw that while rotating, while angular velocity, it was rotating a lot. So I can just keep it 2. So I will save it. Okay, I will open it. I will reset the poses. Yeah. And I will run the auto.py. Okay, just a minute. Can anybody tell what wrong I am doing?
Range will be inside brackets, as 4 will be inside brackets. I guess.
Like this?
Yes, sir.
Yep, range, yeah, that's correct.
Yeah. Again, it rotated a lot. So
just get the pose from it and have a positive control loop, no?
Are you saying about odometry?
No, I'm talking about, yeah, I think odometry, yep.
Yeah.
Oh yeah, odometry. You can get the pose, right?
No, I don't want to go for that, because that is possible, but
positive control loop, which means you have to set up another package and stuff like that. I understand.
Yes. So it is okay if it's not perfect, but I want to give, like, right now there is inconsistency just because of the streaming. So that is the only case. But
you can do a technique which is technically cheating, but since this is gazebo, you can get the moral post from the gazebo, then say if it is if it is near to the.
Yeah,
It's technically cheating. That's why I told you it's technically cheating, but you can do that.
yeah, no, it's okay, it's okay. So I just want you guys to understand like what exactly is happening, and there will be a task related to this as well. And in that case, I don't want you guys to do cheating. In that case, I want you guys to just record the perfect moment in which it happens, okay? And maybe tune the parameters in that way. So let's see if it happens now. No, again, it's 0.1, so it is really less. Okay, guys, so don't worry, I will send you a video what exactly I'm trying to show over here. But basically, did you guys understand the concept of why did we use loop and why did we automate this process? Did you understand this? Samya, yes, what was your question?
Actually, I was not saved that auto.py and suddenly it closed and it all got deleted. So I was told in chat that if you can copy paste it the code.
Okay.
But
No worries, you can like see this recording will be shared and you have enough time, so you can try it later on at night. Okay, so you can try this.
or you can just copy it and paste it in chat.
This complete code.
This code you
Okay.
can if it's possible.
Yeah, okay, I will copy it. Okay. Yeah. Okay, and Joel, tell me. Joel?
It's not related to this part.
Uh-huh.
It's just a general question.
Yes.
So in that simulation, is the robot that was in this simulation, is it 4-wheel drive or 2-wheel drive?
4-wheel drive.
But while we were accelerating, when we gave a velocity and it started, the top lifted up. So doesn't that mean it's a 2-wheel drive?
No. The command velocity has been going to all the 4 wheels, but just the thing is that the torque is so much that it lifted up. So the reason actually in tomorrow's task there will be a gripper in front of that robot. Okay. In tomorrow's task there will be a gripper in front of that robot, and this robot was made to handle that gripper. So right now, if we remove the gripper, the torque is expected. That's the thing. Okay.
Okay.
Yeah. So if you
so how do we actually make this like so we're giving a velocity. How does gazebo know that we are giving it to all 4 wheels?
Okay, so about that, so we are using a gazebo plugin. So if you go into URDF, there is this .gazebo file. So inside that we are telling there is this plugin skid steer drive plugin, and inside that we are telling it we are telling all the 4 joints of the robot. We are telling this wheel separation, we are telling diameter, all this. And this torque is like 5 kgcm torque. Okay, the topic name is command velocity. So all things we are publishing.
So if we are trying to make your own project, then we would have to make this entire file.
Yes, you have to make it entire file.
Okay.
Yeah. Okay, is there yes, Samya?
Actually, I think there is some limitation problem, so that the whole code is not pasted in the chat. So maybe that is the problem. That is the thing. And I have a query, and I have also a general query. Can I ask?
Yeah, sure.
Yeah, I was just asking that can we implement this whole code and what we are seeing in simulations in real world, like
yes,
the same code we can apply, or we have to add anything else?
No, exactly the same code. But instead of gazebo subscribing to that topic, instead of that you have to use the motor velocity or something like that to subscribe to the topic. Okay, so in that case your real motors will be subscribing to that topic.
Like through any controller like Raspberry
Pi
or anything.
Yes, exactly.
So it will be in the next sessions, like upcoming sessions, the hardware part. Or
No. Hardware part won't be there. This will be just simulation based.
okay.
Yes. I will take a screenshot of this, a high resolution screenshot, and I will send it on the group. Okay.
Okay. Thank you.
Okay. Any? Yes.
So you can do one thing. You can go to Haste Code. So that's a website where you can copy paste your code, and then you can send that link. So if anyone opens that link, then they will get the code from there.
You can also use gist, which is
The reason I'm not using paste code is I want everybody to write their own code so that they get to understand the thing. Okay.
Okay.
So that's the reason previously also I could have sent the code files or I would have uploaded on GitHub. But the reason I sent you a screenshot was I want everybody of you to understand the code behind it. Okay. So that's the thing. So try to write the code on your own and try to understand the code at the same time. Is it okay? Hello? Am I audible?
Yes, sir.
Okay. Okay, then I will send you this code screenshot as well. Along with that, yeah, one more thing I want to announce. So right now we were not able to make this complete go in square right now. Okay, just because we were having a continuous video chat as well. But it is possible. For proof, I will be also sending you some videos about the same. But trust me, it's possible. And that's the reason you already know this first task. The second task will be similar to this. So you have to make a script. Okay. So you can make 4 different scripts. You can name it each script some different name. So you have to make 4 scripts, and each script your robot should go in square, triangle, a 5-point star, and a circle. So do you guys know what is a 5-point star? Like a normal 5-point star.
Yeah, regular star. Yeah.
Yeah, a regular star. Like if you just search 5-point star. Yes. Yeah, something like this. So your robot, let's consider your robot is starting from here. It should go like this, like this, like this, like this, like this. So it should move in this pattern. So if your robot moves in these 4 patterns, again the prices are same. You will be receiving goodies at your home worth rupees 600, additional 1000 rupees off in ROS mentorship program, and additional 500 rupees off on total. So these are the 2 tasks. The submission date and everything else is similar. So it will be told to you like verbally through email, but it will be like 22 or 23 of July. So by that time, again, the same parameters. You have to upload it on Instagram. You have to make a video of it. Everything is same, but just the task is different. So are there any questions?
Pancho, I
Yes.
figured it out how to make it stop and make it control C. Do you want me to share the code?
What?
Like you were trying, right, to make it stop and you give control C. I've done it. Do you want me to show you the screen?
Yeah, sure. Go ahead.
Yep. I'll show. Can you see my screen?
Yes, I can.
Okay. So you have to give disable signals equal to true. Then when you accept keyboard interrupt, then I've used the function to set the velocity.
Okay.
Yeah. It's just since ROS uses its own, it uses control C as an interrupt. I mean, it takes over the control, so you don't have control of it.
Okay.
If you want to set it up, you have to give disable signals equal to true, so that you can control that by yourself.
Okay, no problem. Okay then. So you guys understood. So Sas, I would encourage you to share this on the group as well. Okay.
Screenshot?
Yes, this screenshot the code.
Okay.
Whatever you did. Okay.
Okay.
Yeah. So any other doubts you guys have about the task or about the prices or about anything you learned right now? Because tomorrow, now you have understood how you can send command velocity through your code, and now you can move your robot. You have that thing, right? So tomorrow what we will be doing is we will be making a graphical user interface. So instead of typing it from terminal, instead of running a Python script, we will be making a graphical user interface. So just like you have mobile apps for your AC remote or something like that. So similarly, we will be making a desktop application, and using that we will be sending commands to robot. And as I said, it will be also having a gripper tomorrow, and we will be able to control the gripper as well. And using that, we will be giving you the final task, which will have the grand prize and everything. Okay. So any doubts? Anything?
So we were running that auto.py file node like ROS run IRC underscore KT, then auto.py. That was the command, na?
Yes. ROS run, then the name of the package.
Yes, and then the name of the node.
Yes, exactly.
Okay.
So if you want, you can automate that as well. Okay. So if you want, you can make a add that. You know how to add node into launch files. We did it right now. Your youtube.launch. Can you see my screen?
Yes.
So here we added nodes, right? So in the same way, we are launching here gazebo.launch. So in launch file, there is gazebo.launch. So here you can also add a node. You can add a node if you want to automate it. So just like we are adding node over here, you guys can see my screen, right?
Yeah.
Okay. So you can add a node over here. The name of the package is RBL robot description. The name is auto.py, and the name of the node is okay. I will just save it. Now if I run this gazebo.launch, it will automatically launch everything, and it will also start make the robot move. Okay. So you can see the robot started moving.
Yeah, through the launch file we can do everything with only one command.
Yes, exactly.
Okay.
So this is the shortcut that you can have, but it's not recommended, but it's okay. If you wish, you can have it. Any other questions?
Hi, Pranshu. So, a little question. So the thing is, this particular ROS architecture, when we run, we are running it on devices that are physically connected. So, is there a method through which we can run ROS over wireless medium if it is connected to the same? Yeah. So, would you be like teaching that?
No. So as I said, this will be completely based on simulation itself.
Okay.
Yeah. But there are even the tortoise bot. Okay. So we don't run everything on tortoise bot. We have a ROS master. So if you just search over here, as I said, tortoise bot is a replica of a turtlebot 3. Okay. So if you search for turtlebot 3 documentation, there is quick setup, quick startup.
Yeah, basically you add it to your next, yeah.
So in your bash RC, you have to add these commands. So let's consider your robot as well as your PC is connected to the same Wi-Fi. So they would have a unique IP address, right? So the PC on which the ROS master will be running, you have to give the ROS master URI. So both of them will be having the same ROS master, and later on, the host name will be different. So host. Yeah. So that's the reason I showed you the location of ROS master URI. So that is from where you will get it. Okay.
Got it. Sorted. Thanks, man.
Anything else?
For the second thing, triangle, square, circle, and stuff, GitHub code is fine, or just a video is more sufficient.
You will get instructions about that, because I don't have it right now.
Okay.
Yeah. Most probably video will be fine.
Okay.
But I actually don't use the cheating method. Okay, we could ask you for the
Yeah. I mean, No, obviously, because no, I was just wondering because if I have to
Yeah.
submit it somewhere.
Yeah.
I don't mind.
Okay, suppose say we create 4 different Python files for going into square, triangle, and
Yes.
all those things.
Yes.
We'll be keeping those in the launch files, right? In what order will it be executed, or
No,
everything
no,
will be?
no. You don't need to keep it in a one launch file. I just recommended you can do it, but it's not needed. So you can just launch simulation. Okay. Start the screen recording and then make it a square. Then you can stop the screen recording. You can keep that aside, and then you can make another one for triangle, another one for circle, something like that. You can make 4 different videos and you can upload 4 different videos just in one post. That is okay.
Hello.
If we want to, but we can do that, right? Into a single launch file.
Yes, yes. If you want, you can do it into single.
Okay, so if that is happening, then how that what will be the order of execution? Everything will be ordered like sequentially, or
It's upon you. There is no like this thing, but you should at least you should print something on terminal, like square is going to starting, like square is going to make, like the robot is going to make square, the robot is going to make triangle. Just print these things so that we understand like it is making that specific shape.
Okay.
Yes, Tapan.
Hello.
Yes.
Actually, means we for the task 2, where we have to upload the videos.
Same to the task one, Instagram or LinkedIn.
Okay.
Yes.
Okay.
So all the instructions will be provided. Don't worry. By tonight itself on mail.
YouTube. Can we upload on YouTube?
Yeah,
it will be much easier.
the final task will be there for YouTube. So we'll be keeping the final task for YouTube.
Okay.
All these tasks will be just small tasks. So that's it.
Okay.
Yeah. Devansh and Krish. Devansh, go ahead. Yeah, Krish. Tell me.
So when we initialize
yes,
the publisher node,
Huh?
so we pass this argument called queue size.
Huh.
So I wasn't able to comprehend the like why do we use it?
Okay, so
what is the significance of this?
Okay, so as I said, when we are working on real robots, okay, so maybe you are using a long-range robot who might not receive a proper Wi-Fi connection. So maybe if you tell it to stop over the Wi-Fi, it might happen that he might not receive that message and it will not stop. It will keep on going, right? So in that case, you are sending multiple message in a queue, so that it will be considered as backup. So at least if one message is not received, it will receive the second message, at least the third message, fourth message, something like that. Okay. So you should increase the queue size if your communication signal is low with the real robot. But here we are using it with a simulated robot, so that's not a problem.
Okay. And also, will holonomic drive be considered as a combination of linear X and linear Y, or a combination of linear X and yaw?
So technically it has everything. So it has linear X, linear Y, and angular Z as well. Okay.
Okay.
So these are the 3 things which holonomic drive have. Because your holonomic robot can also rotate on axis, right?
Right.
Yeah, and as well it can go diagonally. It can do a lot of things. So that's it. Rest of the parameters are used when used with drones. So if you are making a ROS controlled drone, so at that time you will need positive Z and negative Z. So you might need that as well. Okay, yes, Krish, go ahead.
Sorry, do you want me to show the way how do you download the video?
Yeah, just wait a minute. We will talk to Joel first if he has any questions. Yes, Joel.
So for the task 2, what's the criteria for judging?
So that will be based upon the like what way. First thing will be how good do you draw those things, how accurate it is, and the second thing will be in what way do you do it. Like Harrier said, that can we make a launch file? So maybe if everything is in one single launch file, if everything is automated, that is really good. But it's okay if it is different. You won't get less points for that. But again, it is more upon how accurate these shapes are. Okay, I can consider star won't be the best shape, but apart from that, square, triangle, how good they are. Okay.
Okay, sir.
Yes.
So, okay, fine.
Mm. Yes, if anyone else doesn't have any doubts, then we can move on to Krish, who will show how you can download it. Yeah, and if
Yes, sir.
yeah.
So can I share my screen?
Yes, yes.
I have a doubt.
Yes, Devansh.
Why does the time not sleep function depend on, like, why was the robot not able to make an accurate drawing or follow an accurate path? Shouldn't the time depend on the time that the simulation follows?
No, that time dot sleep we were using it the real time. So that was
So,
the reason.
is there a way to like point that instead of using the operating system, the time that the operating system is using, instead of that, can we use the time that the simulation uses, the time frame?
I should say that you have like got the half thing about the task. Okay, rest I will leave up to you. So that was the half trick of the task. That is possible. I would say that.
But like, isn't it the only reason we do simulation is to get accurate results of what will happen in the physical world? So
Exactly. So you can use the simulation time, and there is a way. I want you guys to explore that. Okay.
okay.
Yeah, there is a way, and that's the reason we gave this task, because we wanted to see who can figure that out. So you already gave the idea to everyone that it's okay. It is still challenging to find that. Okay. Yeah, Krish.
Yeah, yes, sir. Can you see my screen?
Yes.
Okay, so this is the video which everyone has. So what you can do is you can first maybe set what quality do you want, and maybe come a little far in the video, and then you're going to press Control Shift I to get this, and you will go to this network tab. So you will get all these methods and stuff here. So you have to basically filter, yeah. So you will have to filter something called video playback, and once you get this, maybe this is the correct thing. So it might vary, but it usually starts from R. So R followed by number and dashes and stuff like that, and you're going to right click this and then open in new tab. So once you open this in new tab, you can right click here and save video as, yeah. So you can save this video and in any format and stuff, and then you can basically download it. So I'm not going to download it right now, but this is how you're going to do that. So you can do this with any drive file you have got from school or college. So this is one trick which I learned. You guys can also try it out, yeah.
That's really nice. But I guess Indian robotics community have already made it available to download, I guess. But still, if anyone wants to do this with any school or college files, so definitely you can do it. Yes, Manish Nikhila, is anyone here? Manish Nikhila?
Yes, sir. Manish is good.
Yeah, hi Manish. So Manish, we are done for today, and tomorrow's session will be something similar. So tomorrow at 11 a.m. Okay, everybody.
Okay, sir. Okay.
Yeah. Okay. Yeah. So if anyone has any doubts, they can ask for the final time, or else just post it on the group, and we will have a discussion over there. Okay. So bye bye everyone.
Yeah.
Thank you, sir.
Thank you, everyone. It's Mr. Kumar. Abhijit, like we need at least 2 to 3 hours to get the recording. Once we get it, we will share.